Welcome to our last screencast on subroutines. We'll be talking about how to describe your subroutines in your classes. We'll talk about packages. We'll talk about JavaDoc. We'll talk about some assignments and declaration and some variable scope. So let's start off with, you can consider subroutines as a set of black boxes in a class, and you use them for building your program. You need to define the interface, and a subroutine has a very specific interface. Often that's called, for all your classes and all your subroutines, we call that the application programming interface. That describes the kinds of things you can do with your toolbox. There are different APIs for different environments. Windows has a different API than Linux, has a different API than Mac OS. And Java actually has a very large API that's defined by the Java language and by all the classes in the Java toolkit. You can take a look at the Java API if you go to that URL, and I highly recommend that you bookmark that URL so that you can refer back to that to see what are all the different classes that are available for your use for when you're writing programs. So Java organizes its classes into what they call packages, and packages can contain classes, so you would normally put classes that are related to each other into a package, and packages can contain other packages or sub-packages. So you can have a hierarchy of packages. And in Java, there are two major packages. The Java package, which includes a lot of the core parts of Java, like strings and ints and floats and other things. And then another package, Java X, which was added on later, that includes other kinds of things that were added to the Java core. I think they used the X for extension. They added another GUI programming. In the original Java, they had a GUI programming API called java.awt. When they wanted to update the way they did their handling GUIs and windows and buttons and stuff, they added Java X Swing, which is their new or improved drawing tool, graphics tool. So you can imagine Java sub-packages as being boxes inside of boxes. We've already seen how Java lang math, we've talked about the math class, has a bunch of nice functions like square root, which calculates the square root, or random, which calculates a random number. We talked about the string, so if you want to refer to the math square root function, you actually say the full name is java.lang.math.square root. So we talked about strings. They are part of this lang package. Integers, floats, doubles, a lot of other things. System is in the lang sub-package. The AWT package is the one we're talking about. It's a window kit. Allows for drawing things in Windows. It has a graphics class. We talked about that earlier in this, or I guess last chapter. So if you want to refer to the drawRect subroutine, you would say java.awt.graphics.drawRectangle. DrawRect. It has a set color. Inside the AWT package, there's a class color that defines color. So when you set color, you supply it an instance of a color class. It also has another thing for fonts, for changing the fonts. And then another very useful package that we won't quite get into in this class, but next class we'll talk a lot about, or next year we'll talk about, next semester we'll talk. Java util has a lot of very useful classes, utility type classes, data structures, lists, arrays, those kinds of things. Very useful package to know about when you're using Java as your programming language. So how do we use classes from these different packages? And there are hundreds and hundreds of these packages. Well, there's two ways to do that. First way is to actually use the full name of the class. So we can declare a variable rectcolor, and it's of type java.awt.color. So we just give it the full package plus package name plus class name, and we can create the variable. And that's all we need to do. That just gets a little bit cumbersome to always have to refer to it java.awt.color. So the second way is we can import the class using the import command right here. So we say import java.awt.color, and now for the rest of our class, for the rest of our file, we can just refer to the class name color because we've already imported that, so the compiler knows that when we say the class name color, we're actually referring to the java.awt.color. So that makes it much easier for us to, it doesn't require so much character strokes to refer to the color. So we can create our private static color, rect color, or we could have said private static java.awt.color, rect color, and both are same. We don't need to do the import, but using the import makes your life a lot simpler because you don't have to type so much. So there are multiple ways for importing. If you want to import all the classes of a package, you can use the wildcard asterisk. So if we say import java.awt.asterisk, that imports all the classes in that package, but it does not import any sub-packages or classes in sub-packages. So for example, if you thought, I want to import everything in Java, the Java package, so I want Java lang, Java AWT, Java util, if I say import java.wildcard asterisk, that actually doesn't import anything because there are no classes in the base Java package. They're all in sub-packages. Some people consider using the wildcard a bad style. I'm sort of on the fence to that. I don't like just blindly importing all the classes from a package unless I actually do want to use a lot of classes from that package. Some people say that just blindly importing all these things, you're sort of wasting resources because the Java program has to sort of import all these things, then find out it only used one. I tend to like to start by importing the individual ones, but if I get to some number of 5 or 10, then I might switch to doing the wildcard, because after a while it gets very cumbersome to keep typing the import statements when you can just do import asterisks. So not only can you use the Java packages, but you can define your own packages. So let's say you want to create a utilities package where you could put a lot of your classes that you're developing that are helpful in different things. To create a new package, you create a directory with the name of the package. So here's my command line, mkdir, which just makes a directory called utilities. I then cd into the utilities, and then I create my Java files in that directory. And to indicate that they're in the package, I need to include the package utilities line at the beginning of each Java file. And that tells Java that this Java file belongs to the package utilities. I can do my imports, and then I create my class. And now this class is actually in the utilities package, so its full name is utilities.example. And again, since I imported color, I can create a variable of type color. It's actually of type Java AWT color, and I can continue on my merry way. So if I wanted to import my example class, I would, in a different Java class, I would say import utilities.example. Now you don't have to import classes that are in the same package. So if I have another class in the utilities package, and I want to use example, I don't need to use the import because they can see the classes in the same package. So how do we describe, we've constructed all these packages and we've constructed all these classes, and we want to describe the API for our program. Well, Java has a tool for building API documentation. It's called JavaDoc. In the code, you put in these special comments, which are /**, and then the comment, and end the comment with a //. The JavaDoc tool will parse your code looking for these comments and produce HTML pages describing your classes and all the subroutines in that class. Since it's producing HTML pages, you can put actual HTML inside the comment, and to make your documentation look pretty, you can use bold tags, paragraph tags, italic tags, anything you want. You should also use these special tags called doc tags. Doc tags begin with an @ symbol. So like at authors, at the beginning of your file, you might just document your class and have your @author tag and put your name because you take credit for your work. For every subroutine that has parameters, you want to have an @param tag for each parameter. If the subroutine returns a value, so it's a function, you want an @return. And then if it throws any exceptions, you want to say @throws. So the idea is param, you describe the parameter name, the description of the parameter. The @return, you describe what the return value is. The @throws, you describe the type of class, the exception that's thrown, and a description of what the exception might be. For example, you might say throws an illegal argument exception if x is less than or equal to 0 for some cases. So let's look at an example. So here's my JavaDoc comment for the area of rectangle function. I have a brief description of what the subroutine, the function does. I have a param tag for the width and for the height. I have a @return that describes what the return value of the subroutine is, and it just throws showing the legal argument exception if either the width or the height is negative. So here we see that where we do our check, we throw our thing, we define area, we calculate its value, and we return it. So that's a simple JavaDoc description of this subroutine. The JavaDoc would produce a nice HTML page for the class that has this description for the subroutine. So we talked about importing things. If we want to import static classes or static members, for example, if you want to import the out static member of system, you can say import and with the static keyword, and you got to supply the package name, class name, and then the member, static member. So you can import static members, which are member variables, or static methods or subroutines. So if we do import static Java lang system, because that's the full name of the package, right? Java lang is the package, system is the class, out is the member. So later on in our program now, we can just refer to out directly. We don't have to type system.out. You can't static import from a default package because the default package has no package name. So what would you put here for the package name? You can't, because you need to have a package name. So you can't use static import for any classes in the default package. So let's step back a little bit and talk about, now that we talked about subroutines, and let's go back and talk about how we do top-down design. So we talked about stepwise refinement, where you describe the problem and you describe the steps to break down the problem, and you keep breaking down each step until we finally get to the bottom. And so before we had subroutines, the bottom was we got all the way down to these pseudocode statements that we could directly replace with Java statements. Now we have subroutines. We can stop before we get down to the finest level. We get down to these subroutines or tasks that we can describe as saying, oh, I need to calculate an average. Well, I write a subroutine that calculates an average. So now, remember, now we don't have to go quite so far down. And remember now that we can have subroutines can call other subroutines, so you can construct these boxes that get used in different places. So those are the tasks that get referred to again and again. So we don't have to go quite so far down, and we can actually build up these subroutines that we can reuse again and again in our programs. So one idea for describing these subroutines and these tasks is to describe the contract, right? We talked about the contract, is what it does and what you have to do. Then we have this concept of preconditions and postconditions. A precondition is something that must be true before you call the routine. It's the job of the programmer who calls the routine to ensure that the precondition is met. So for example, with the math square root function, the precondition is x is got to be greater than or equal to 0. If x is less than 0, something bad could happen. It's a precondition. Square root of a negative number is an imaginary value. This math returns a double. That's not an imaginary number. So if you gave math square root a negative number, it's probably going to throw an illegal argument exception or some other kind of exception because you violated the precondition. A postcondition is something that's true after the subroutine runs. So that's sort of the contract. It's this subroutine promises to do something. So the post condition on math square root is that the return value is going to be squared is the value of the parameter passed in, right? So the return value will be the square root of the parameter passed in. So the post condition is, if you call math square root, the answer will be squared, will be the parameter you passed in. So you can often add the precondition and the postcondition to your JavaDoc comments. In fact, some people suggest, and it does not exist, that you would actually have an at precondition and an at postcondition doc tag, but they don't exist yet. So you can just put in a little description saying precondition, x must be greater than or equal to 0, postcondition, the return value will be the square root of the parameter. So let's talk a little bit about declarations. We briefly talked on it before. We talked about you must declare all your variables before you use them. Variables need to be initialized before they're used. So an example, you would say int count, that declares the variable count of type int, allocates the memory, and then when you initialize count to 0, that actually assigns the value 0 to that memory location. We can combine that into one statement, int count equals 0. That's just a shortcut for us, it's a convenience. The program actually still does a two-step execution. It allocates the variable count and then initializes the value to 0. You can initialize several variables in one statement if you use a comma. So int x declares x, y, comma, y equals 1 declares y and assigns it to 1. So only y is initialized after this statement. X is not initialized, but they're both declared and they can both be used. This is very useful in for loops because we can shorten up the for loop by saying for int I equals 0. So we declare a variable I, we assign the value 0 to it, and then we can use I in our loop. So I is less than 10, increment I, and then we print out I. And so now that will print out the values 0 through 9. So it's very nice, it's a very convenient way to declare and initialize in one statement. So you don't have to do the declaration and then later on do the initialization. You can do it all in one statement. So we can do the same thing with member variables. For example, we have the class bank, we have a member variable interest rate. It's a private static double, and so that this will declare interest rate and then initialize its value to 0.05. And then we private static int max withdraw, assign it to 200. Declarations are the only statements that can occur outside of a subroutine. So if we try to do this in two steps like we did previously, where we declare the variable, private static, but we can't do the assignment statement outside of a subroutine. We could do the assignment statement inside a subroutine, but out here, this is at the class level. This is outside all the subroutines, so this is actually illegal, and the compiler will give you a compile error. So we need to do it all in one line, like we did up here. We can't do it in that two-step process. So sometimes we don't want variables to change. We actually want it to be a constant. So for example, in our previous example, we have the bank. We have the interest rate at 5%. We don't want someone later on to just arbitrarily change the percent to 10%. That just doesn't make sense because often things like interest rates don't change over time, but maybe they do change. But if they do change, we would probably rerun the program. So in order to create the constant, we can use the final modifier. So we say private final static double. And because it's final, it can't be changed. That's the rule. You cannot, it's a compile error if you try to change the interest rate to something later on. So the compiler will make sure that this does. And because we made it final, we tend to want to change the variable capitalization so that it's really obvious that this is intended to be a constant. So what we do is we capitalize all the letters in the name, and we use underscores to separate the different names. So now, because we made it final, we changed the name from interest rate to interest rate, and now interest rate cannot be changed. The compiler will not allow interest rate to be assigned to something else. So that's a very nice way of creating a static that we can refer to, a constant that we can refer to later on in our program by just referring to interest rate. It's a very nice way of making your code a lot clearer, because if you just saw the variable interest rate that's not constant, well, you'd have to sort of say, is that supposed to be constant or is it not constant? And if you saw a bunch of 0.05s everywhere, what does that mean? It doesn't have any real meaning, whereas interest rate tells you sort of what the purpose of that value is. So that leads us back to naming and scope rules. We talked about this briefly when we talked about the block statements, because they can define scope. But the idea of a scope is, where is a variable usable? Where can we use the variable? So we've declared it, so it is useful all the way through. And in this case, we've declared a member variable, int count, typo, that is valuable, defined everywhere for the class. And then inside this method, or subroutine, we've defined a local variable int. Now, the int count member variable is available outside. It's actually available inside until we declare that, and it's available after. The local variable count is only available inside the subroutine play game, and in fact the member variable count is not visible because the local variable masks or hides the member variable. So all the references to count inside a play game are referring to the local variable, not the member variable. So it's a little bit tricky if you're going to use local variables that have the same name as member variables, because you've just hidden the member variables. So let's talk about another way. So if you say, I create this local variable and then I want another variable x, you cannot redefine x inside the subroutine, because we already have an x, and x is available for the whole subroutine. So if I wanted to actually have multiple x's, they have to be in their own block here. So x is not defined in the subroutine, is just defined in the block. This second x is fine because this first x goes out of scope when we leave this block, and so now we can create a new x, and that's fine. So the difference between this is, this x goes for the whole subroutine. We can't override the local variable. And here, this local variable is not overwritten, and this local variable does not override and this local variable.